All right. Hello, everyone. Can you hear me? Can you see me? I can't see you, so you have a disadvantage. Welcome. Thank you very much for choosing this talk among all the super interesting proposals that are happening in the other rooms. My name is Milen Dyankov. I work for a company called WorkSonic, and my role is a developer advocate. And basically, that means I tend to go to events like this, tend to go to people that use our software, speak to a lot of software developers about event-driven systems. Because that's what WorkSonic does, is we help software developers do distributed, highly scalable, event-driven systems. And when I say that sentence, you all know what I'm talking about, right? Of course not. Because what is an event-driven is something that has a different meaning for everyone. That's the thing that I came to discover over the years, is we use the same word. We assume the other person has the exact same understanding of that word, but in reality, that's often not the case. And so that is why this talk, to try to talk about some concepts, some approaches that we do, and what exactly that means, and how that translates to like technical terms and things like that. So a lot of things you'll see and hear may not come as a surprise. There's going to be a lot of things that you probably already know, but hopefully you still learn something and you get this information together in more concise or consistent form. So please join me for this journey through the event land, where we'll explore different things related to events. And as with every journey, we'll start it at the front door. So in there you have a door, and it has two things. It has an ID, that's 28, and it has a property of color, which is yellow. Wait, it's red. What happened? Now, think about storage for a moment. I don't really care what is your preferred way of storing data, but for as long as you store state, whether that's going to be a database table or NoSQL, key value, well, I probably wouldn't use graph for this, but who knows? Well, you store the state of something as of now. So if you look at your storage, whatever that is, it's going to say there is a door, it has an ID 28, and it's red. And now everything this door had in the past is gone. That may or may not be a problem. It may be a problem if you need to answer any of these questions. Like, why it is red? Because I remember it was a different color. When it became red, like who caused it to become red? And what was the color before? Now, if none of those questions are of interest to you, then it's okay. You can just store the state as of now, and you're good to go. But if you need answers to any of those questions, now your storage does not provide those answers to you. So what if, instead of storing state, you store changes? Store an event that causes something to change. Like this. Joe painted door 28 red yesterday. Now, if you choose a storage like this, then you can reason about the current state. After the change, the ID is still 28 and the color is red. But you can also answer these questions. It's red because it was painted, changed yesterday. Joe did it. Now, the only tricky part is, what was the color before? I mean, obviously, you could also put that in that storage, like from yellow to red, but you don't have to. Because if you store events that are a result of changes, then most likely you have this event log somewhere where you can go and look for past events. And there's going to be some event related to door 28 that says a yellow door was installed. And since there are no more events between those two, you can safely conclude that the previous color was yellow. So if any of this is a concern to you, answering those questions, the concern to you, storing state doesn't really help, right? It's much better to store events. And now, when I mentioned the word event so many times, let's go for the basic definition. So what is an event? Like, it has so many meanings, so let's clarify it for the purpose of this talk and also for the purpose of the conversation that we can have. Event is a notification that something has happened. Now notice the past tense. It has happened, right? Period. Now why is that important? You probably heard many people telling you events, past tense, blah, 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 but why is that important? It is important because it brings a feature that we developers love, and that feature is immutability. If something has happened, that's it, it's a done deal. We don't change it, it cannot unhappen, it cannot disappear, there's nothing you can do about it, it just happened. And this is like things in real life. Things happen, you have to deal with them, right? You can do other things to recover from things that have happened, but it don't change the fact that something has happened, right? So immutability, and why as a developer, we love immutability because it's so much easier to work with and so less prone to errors. Or as Martin Fowler puts it, when you start storing events or dealing with events, you are making a change a first-class thingamajig. So you all of a sudden have a way to represent a change in your code. Something was like this, and now it's like this happened, and now it's this, right? So if you only store state, you know, you only operate on state, you know the state as of now, but everything on the past is lost. But if you store changes, if you have a way to represent changes in your code, then you know exactly what happened. You not only know where we are, but also how we got there. And that in many cases is a very powerful thing. But how do we design systems this way? Well, there are two techniques. There are more, of course, but two that I'm going to mention in this talk. And the first one is event storming. So I would normally ask you if you heard of event storming, but I will not because I can't see you anyway. So I'm just going to go ahead and explain it. So event storming is a business process discovery and design technique. So basically means you try by using events to discover what's happening in a system, right? It was introduced by this guy, Alberto Brandolini, I think circa 2013. And the idea is that you build a shared understanding of the system between the software developers and the stakeholders, the business guys, the domain experts, pretty much everyone, right? It kind of works. I'm not going to go into many details. I'm just going to give you the overview. But it's essentially a giant board of sticky notes. And you got all those people in the room and basically start discussing like what can happen in this system, like what events are there. This can happen, that can happen. And then you start reasoning about why it happens, what causes it to happen, and whatnot. And then you discover what processes are in the system. I don't know how many of you attended a talk this morning about domain examples, I think it was. It was another approach, kind of a high level or kind of next stage on top of event storming. So there are different variations you can do about it. The main idea is the events, the things that happen within the system, define the processes, define how the system behaves. And there is another technique that is maybe less popular, or growing in popularity anyways. It's called event modeling. Now, event modeling, and some people may argue it's kind of the same thing like event storming, but I think it's a little bit different. It claims to be a technique to have a blueprint for a solution. So not only discover the process, not only discover how things do operate, and then you figure out implementation on your own, but this is like kind of designing the implementation while you discover things. This was introduced by Adam Dimitrick, and what he suggests is to put the events on a timeline, because you can roughly tell which event can happen before or after another event, right? And it doesn't have to be super precise, but overall, you know that before you do a checkout on a shopping cart, there has to be a product in. So, you know, kind of able to tell which events are happening earlier, which events happen later. And then you put all these events on a timeline, and that's the blue nodes in the middle. So these things can happen. And then you start from there. It's like, okay, if this can happen, like, what is the component that causes it to happen, right? And so there's some components that produce that event. Then you think about, like, okay, but when this happens, what the system should do? Well, there should be an event processor that handles this event and does something, right? And so on and so forth. And you can even go up to the point where for all these components, you can design that, okay, for this component, there must be a user interface, right? Because the user is providing the data. So for this particular case, you provide user interface. And things like that. So it's kind of not only discovering the processes, but also kind of the initial design of the system. So Adam claims this is very practical approach, and I particularly like that tweet he did some time ago. They were doing this exercise, and they discovered, like, modeling a zoo, and they discovered this event. Now, that's maybe a joke, I don't know, but it highlights an important point. When you model systems this way, you discover things, and now you're free to decide what to do with it. Maybe you want to just ignore this and say, like, nah, that's not going to happen. Like, we don't have to handle this. Or maybe it's an important case that you need to handle, and then you need to build some infrastructure around that. That's the important part is if you don't do event modeling, if you don't do design considering the events first, it may never ever occur to you that something like this may happen, right? So those are like two of the many techniques to design event-driven systems. And then what is an event-driven system? So like we said, event is a notification that something has happened. So it's essentially something that holds some piece of information. And then you have these components that produce events. They basically tell the world something has happened. Right? And then you have some other components that are interested in events. They want to know what happened. Now, I really want you to think about this as a roles. No, that's not a Java class or particular implementation. It's the role that a component plays, right? There could be a component that is both producer and consumer, and that's totally fine. In terms of roles, though, some components have some data. They perform some operations and tell other components something has happened. Now, you need to have something in the middle that is capable of delivering those messages, because events are messages, essentially. You need something in the middle that delivers this message from the producer to the consumer. And for the purpose of this talk, we'll call it a message router. And I'm deliberately using the word message router and not event router, and you'll see why later on. And so this is, once you have an application that works this way, you start claiming it's event-driven. And for those of you who are very impatient, already thinking, yeah, I know that box in the middle, it's Kafka, right? Okay, raise your hand if you thought that. Yeah, I know. Well, yeah, Kafka can do, but it doesn't have to be Kafka. But anyway, you're now event-driven, so super cool. But what you're actually doing this way is you entering the buzzword land, right? And then event-driven is also a buzzword. Every time we have something like this, we start using event-driven as a buzzword. And there's nothing wrong with that. I'm not complaining about it. Actually, it is great for product pitches. Like, if you have the right audience who is interested in this kind of things, you can go ahead and talk about how great event-driven products you have. It's Google search, people search for things like that. Hell, we do it. If you go to the Axon Framework page, it says it's an event-driven micro blah, 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 right? So it's okay, it's totally fine to use the event-driven as a marketing buzzword and whatnot, for as long as you understand the context in which you're using it, right? And you don't refer to this as a I don't know, software design technique or something, right? If you clear that you're using it as a marketing term, that's fine. Another thing that event-driven is, it's a false claim. And the reason it's a false claim, it gives you the wrong impression that events are the driving factor. Like everything in a system happens because of an event, right? Well, that's not true, because as we said earlier, events are notifications. So they basically inform something has happened. But why this thing happened, it's what's causing the system to do things, right? So all the systems are driven by decisions. And those are the decisions made by algorithms, made by you as a developer, made by artificial intelligence, if you will. I don't know, but at some point, something decides to go left and not right, to do or not to do something, right? And that is what drives your system. Now, the events are merely a notification that a decision has been made. And that's the result of that decision. So be very careful when you use it as that shortcut, because events are not really driving anything. They just tell other components what just happened. So yeah, events are the outcome of those decisions. Now, another thing event-driven is, it's a polysemy, or other words, lexical ambiguity. And I'm not going to dive very deep into that, but as Angie called him yesterday, the everyone favorites software journalist, Martin Fowler, has a very good talk on that. Those are the URLs. The talk is titled "The Many Meanings of Event-Driven Architecture," and he goes in more details about what different people mean when they say event-driven architecture. So I'm not going to repeat all that, but I'll piggyback on two things, which I think are important to understand. And there's two communication types within event-driven systems. The first one is event notification. So event notification is something like shouting out that something has happened without telling actually too much about it. So you basically send an event and say, this happened. And you don't expect, and that's true, by the way, for all events, you don't expect any response to that. You just notify the world, right? And in most cases, the order in which notifications are sent is significant. There are some edge cases where it may not be, right? But essentially, it's kind of like LinkedIn sending you a notification. Someone visited your LinkedIn profile. Well, thanks, LinkedIn. It would be nice to know who and what they did and what. Now, but there are no details, actually. The only thing they said is, like, this happened, and if you want to know more, you have to click on the link, go to LinkedIn website, and actually check for as much as you can check what actually happened. And so this is essentially the same thing when we have event notification within software systems. You just send a message, basically says something happened. And if the consumer of that message wants to know more, they need to do a callback. They need to call the originator and say, oh, I got your notification, something happened. Can you please tell me more? Now, the other approach to that is to do what's called event-carried state transfer. And so event-carried state transfer is like putting all the information that you have on a pen drive and send it to the person and says, like, here it is. Everything I know, so don't bother me, right? And so it's the same thing, but there is no direct communication back. You kind of cut the call me for details thing. So it's just one way, and you assume that every single piece of information that's important for the consumer has been provided as part of the message. Right? Now, that is a better approach in the sense that it gives you greater resilience and then maybe reduces latency because they don't have to call you back and things like that. But hey, it brings you to the land of eventual consistency. So let's talk about that for a moment. That's how it works. You send a notification with all the data in it, and now that guy on the other side needs to make own copy of the data. Now, it doesn't have to be exact copy. It can just extract information that is important for that particular service, But unless it is a stateless service that is just doing something and forgetting about it, it has to have a local copy of that data. So it can operate later on some data, right? And so you're duplicating the data between the services, which brings us to an important question: where is the source of truth? What happens if two services, now that you have data in two places, what happens if these two places claim different things? Which one's right? Right? And it could be very hard, if not impossible, to tell. So for the event notification approach, it doesn't really matter because there's one source of truth. Every time you want to know more, you go call them, and then they operate on one thing and then tell you, and that's it. But when you do event carried state transfer, you have two sources of truth, and they may claim different things. Your consumer data may say it was paid, while the main or the producer data may say it's not paid. So you don't know which one's true. So how to deal with that? Well, there's the concept of event streaming. So we have this message router in the middle. All the messages go through that router anyway. So what if we introduce a stream of events over there, or messages, and just store that? Now, if we do that, our consumers don't have to do local copies anymore. All they need to do is keep track of where they are in the message stream. So how many messages they have read, and then read the rest every time it appears. And if they want to, at some point, if there is a conflict at some point, what you can do is you can just go and reread the entire stream. And that's also something that Kafka can do. It changes nothing for event notification because things still work the way you need to go back and ask, but it changes a hell lot for state carried event transfer, event carried state transfer, because now this storage there becomes essentially a cache or disposable data. You can keep it for conveniences, for optimizations and things like that, but at any point in time you can get rid of it and reread the whole stream again and rebuild it, right? And so now your source of truth moves in the middle of that picture, and that event stream in the center of your messaging platform becomes the source of truth. And that's the time where if I would see you, I would see smiles on some faces saying, yeah, that's how Kafka does event sourcing. Well, no, that's not event sourcing, to be honest. And we'll talk about event sourcing next so that you know what actually is. And event sourcing is basically going even further than that, because in this picture, you still have two sources of truth, one in the middle and one on the producer side. And there still can be differences between the two, and it still may be next to impossible to tell which one's right. So how do you solve that? Well, let's get rid of the data on the producer side. And now that's a scary thing to do. Like, okay, wait a minute. Like, how come a producer can send a notification and operate and all if they have no data, right? I mean, like, initially, when you look at it, it's like kind of makes no sense. But you need to take a step back and think about how come the producer has data. So there's many different ways of where this data comes from, but just for example, if you have a database, and you are in the Java world, you most likely have some sort of JPA solution, and what happens is, when you instantiate a component that is a producer, some pieces of code that you may or may not be aware of goes to the database, reads a table, a record, a row, or whatever, and then goes to your object and sets fields. It's like, set this field to this value, this field to this value. And once it does this, it tells, oh, here's your object, now you can work with it. And if you're doing things like Spring Hibernate and whatnot, this happens behind the scenes, so for you, it's kind of like, it's always there. Like, you don't really care, right? But what if you apply the same approach? Now that all these guys are producing events, and all the events are stored in the middle, what if we replace the database with our message persistence that we have in the message router? So essentially, we do the same thing. we go and read the entire message stream, but with the only difference this time is give me all the messages that I have produced in the past, right? So only the messages that came from me, now give it back to me. And then rebuild the state of that producer from the very same message stream that you use to notify your consumers. And in that case, you don't need to store the data anywhere. You can always rebuild the component from past events. And that is what event sourcing actually is. And then you have a single source of truth, because there's no difference. Now, well, you can, again, use databases and caches and whatnot on both sides, right? That's for optimization purposes, but your source of truth is in the middle. That is the thing that tells you what exactly happened, when it happened, why it happened. And if there is any conflict, you can get rid of anything else and go back from here and recover, right? And you can actually automate that process now. You don't have to do it manually. So this thing in the middle is called event store. It's a thing there that is specially designed to store events. And now you can be like, okay, wait a minute. I can just use a database, or Kafka is working on some other solutions that that store events and whatnot. But it works. Yeah, it can be done. There is a problem though, that if the solution is not dedicated for storing events, it will degrade over time. The special thing about event stores is that they're specifically designed to store events. And what that means is they are append only. So you cannot modify an event, you cannot delete an event, you cannot insert an event between any other events. Basically, the only thing you can do is append an event at the end, right? And in traditional data stores, because they're general purpose solutions, they cannot afford to do this. They have to support all these operations. So naturally, performance-wise, event stores are much, much better in terms of performance when it comes to event stores versus implementing an event store on a regular database. Now, the one thing that an event store needs to do is needs to provide you a full sequential read. So basically say, give me all the events from 0 to now. And you get a stream of all the events, no matter who produced them, no matter who they were meant for. You just read the entire store. That's a functionality that you need to have. Now, if you want to implement this on a database, for example, and you want to avoid tons of table joins and things like that, that means you have to store all your events in a single table, which is probably not very convenient considering the next requirement, which is it must be able to do replace. And replace is basically saying, give me all the events that I care about, right? I am an event processor, event consumer, and those are the types of events that I care about, so I just want those. I don't want the entire stream. I just want these events that I care about. Now, if you have all this in one table, well, yeah, indexes and whatnot, but still, performance-wise, it's not going to work very well. And that's from consumer perspective, but from the producer perspective, or an aggregate perspective, and aggregate is here a term from domain-driven design, that's a different story. The aggregate says, I don't really care about all the events. I only care about the events that I have produced in the past, because the only thing I want is to rebuild my state once I'm instantiated, right? So now, if you want to implement this with a traditional storage solution, then it's a different way of designing the storage to support that case. One of the most important things an event store needs to provide is snapshots. Now, what are snapshots? Even if you have a small aggregate, chances are at some point in time a single aggregate or a single producer will produce a significant amount of events, like 1 million events, for example, per instance, right? And so now that you're doing event sourcing, essentially what you're doing is you start with an empty object and you go and you read all the events, and then you apply an event and you apply an event and you apply an event, and when you're done, your object is ready to go. And if you have to do this 1 million times, every time you load an object, sooner or hundreds of millions of times, Sooner or later, this is going to reach the point where loading an aggregate is going to be so slow that it basically it's not going to be useful for any practical reasons. It's going to be useless, right? So what you want an event store to do for you is so-called snapshot. You basically configure the event store per aggregate or per producer and say, well, I want you to do a snapshot every 100 events, or every Friday, or whatever is your business condition that makes sense. And then the event store automatically creates those snapshots for you, basically storing the state of the aggregate as of this particular moment in time. And then when you say, give me all the events for the aggregate, the event store actually goes and finds the latest snapshot, loads the state from there, and then applies only the events that are newer than the latest snapshot. And this way, you never lose history. You always know exactly what happened, when happened, but you have the performance that you need on a day-to-day operations, and you can load your stuff much faster. And last but not least, a feature that an event store typically has, or should have if you're looking for one, it is partitioning and archiving. So I don't know in what types of systems you are involved, but for example, if you do any sort of financial systems or like invoicing and stuff like that, there is a reason why they close years. Right? And what typically happens is, at the end of the year is closed, then you move to some new partition or database or whatever, and then you operate only on that. And the reason is, you don't want to lose the invoices for all the years in the past, but you don't want them to hang around on your day-to-day operations, because an invoice you issued 5 years ago is probably not relevant to the decisions that you make currently, but you still don't want to use that information. So what you want to be able to do is partition your data, move the stuff that you just keep for historical reasons to some other cheaper, slower, whatever places, and you keep your most important stuff that you need on a day-to-day operations handy and quick and easily accessible. So those are some of the features that an event store needs to have in order to do this type of system. And so, are we event-driven yet? Like, okay, we have producers, consumers, events going on, have the event store, the stream. Like, is that the point where we can claim we're event-driven? Well, as I said earlier, you can claim you're event-driven at any point in time. It just doesn't mean other people will understand what exactly you mean by that. But if you ask me, no. There's still two things missing here. And those are things that I call passive-aggressive events. Now, you probably never heard the term, let me explain with an example. So here is an event. It says, Joe ordered to paint door 28 in red. Now, what is this event notifying you about? Like we said, events are notification that something has happened. Now, what has happened? Well, Joe ordered something. Is that an important business information? Well, maybe for auditing purposes and whatnot, but it's not the most important part of that sentence. The most important part of that sentence is someone needs to paint a door. And the reason I'm pointing out this is because this is in reality not an event. It's essentially a command. You are requesting a particular someone or to do something. Like, imagine that in this room, or we are in a company, and then you go and tell the entire company, someone paint the door, please. Like, that's not how it works. You typically tell a particular person or a particular department that you want this to be done, right? And explicitly, quote unquote, command them to perform an operation. But one thing that we do when we are so focused on event-driven is that everything must be an event, like event, and then we try to masquerade things that are not events, like commands in this case, as events, right? And then try to apply the same event processing techniques for things that are not events. Here is another example. Joe asked, what's the color of door 28? Now, you already know that's not an event, obviously, because you're smart people, you know where I'm going. So that's a query. That's a request for information. And now remember when we talk about notifications and events, we said they require no response. When you send an event, you notify about something and you don't expect anyone to respond to you. Well, guess what? In this case, the response is the only thing you care about. Like, if no one answers to this, it doesn't make any sense. It doesn't make to store that event because, like, you didn't get an answer you were looking for. And also, this is where the biggest problems I've seen in event-driven systems start to appear. When you masquerade requests for information as events, then the design of the infrastructure, how to handle those and how to send responses back becomes a bigger nightmare. So if you were doing this with Kafka, for example, you would have one topic where you would send this quote-unquote events, and then you probably would have another topic where the answers are going back. But let me change that Joe didn't ask for door 28, but it asked for all doors. And now, the correlation part of like which stream I need to process and how to, combine the results to produce a single meaningful result and whatnot, that's where event-driven systems become really a nightmare. And it's not because of the events per se, but because we try to model things that are not events as events because it's so focused on everything has to be an event. So, remember when I said that I'm going to call that thing a message router and not an event router? And there's a good reason for that, because events are messages, but so are commands and so are queries. And so if you have a message router that is capable of delivering messages, you can deliver other types of messages than only events. So you can deliver commands. So now you can see it goes to a specific component and ask that component to perform an operation. It doesn't go to the event store because commands are volatile, they disappear. You asked them to do something, they do it, that's it, right? But when they do it, they produce an event, and that event, it stores in an event store, so you still have a history of what exactly happened and what caused it to happen. And then you have a message router, you can do the same thing for queries. You can route queries to particular components that know how to answer those queries. And now, you can have a dedicated component that prepares data that returns the right thing for the person or thing that is asking. And that right thing could be a JSON, could be XML, could be PDF, I don't know, whatever structure. It's more convenient for that, for the thing that requests it. The important question is, how do these things synchronize? If query is going somewhere else and events and commands are going somewhere else, like how do they sync? Well, that's the entire stuff that we were talking before, events, right? Every time a command is performed, it sends an event, something has happened, that goes in the event store, and then the consumers are notified and they update their local projections, and you can have tons of local projections, and then the query is going to the component and gets the most convenient result. So, maybe some of you are asking yourself now if I silently introduced the CQRS, and the answer is, yeah, exactly, that's what CQRS is. Well, let's talk about that briefly. CQRS is essentially the idea of having distinct models for commands and queries. It started simple when Greg Young introduced it back in, I don't remember, 2010 or something. And he was supposed to have a talk yesterday, I believe, about how it all started. So I was super excited about updating that slide maybe, but unfortunately the talk didn't happen. But the initial idea was super simple. You have a read object and write object. Everything that only reads data is in one object. Everything that modifies data is in another object. And that was like very, very simple definition of CQRS. With time, things evolved, and we're not talking about objects these days anymore. We talk about models. And the reason we talk about models is like you can't really represent everything within one object. So you design systems in a way that you have a model, group of objects, some structure, a graph, whatever, that represents all the data that it needs to represent that is used when you modify things. That is your right model. That is your command model. That is the best way you represent data in structure, in memory, for changes, right? But that may not be the best model for answering questions. It may not be optimized for answering questions. I'll give you an example. Maybe you have a shopping cart and maybe you need to generate invoices, right? And then if you try to squeeze everything in one model, all the details that need to go into an invoice have to be in this model, but these are not important things when you actually purchase things, right? You're just collecting data, right? But if you focus on what needs to change and then just pass that data to the query side, the query side can build a projection with all the things that it needs for a list of products purchased, or it can build a projection that is essentially a folder on disk with PDF files pre-generated, so when someone requests an invoice, it just serves them a file, right? So the separation allows you to have one model that is best designed for changes, and as many as you wish models that are best designed to serve the need of the thing that requests that information. And the synchronization between the command side and the query side is done through events, which is the picture that we've been discussing for the last 30, 40 minutes or so. So at this point, I think we pretty much covered it all. And this is what the company I work for, WorkSonic, means when the people there, me included, say event-driven systems. So if you look at someone with a WorkSonic logo and they say we do event-driven systems, well, that's what we mean, right? We mean there is a single source of truth, there is a separation between commands and queries, and whatnot. And we build products to support these types of systems. Now, I'm not claiming that everyone should do these types of systems. Like maybe it's not suitable in some cases, but in a lot of cases, it actually helps a lot. And to help people do this, we have this box in the middle, and that is what a product called Axon Server. And the alternative is WorkSonic Cloud, which is essentially a managed by us version of Axon Server in the cloud. Now, Axon Server comes in two flavors. One is a standard edition, which you can use for free. The source code is available, even though it's not purely like it's not the open source certified license, but there is the source code is available. And there is a enterprise version which comes with a lot of features on top of that, like support for GDPR, data encryption, clustering, multiple bounded context, and things like that. And then that covers that box. And Axon Server is essentially two things. It's a message router, think of it like Kafka, and it's an event store, a highly efficient event store that can store events indefinitely. And so you can just put it in the middle and then design systems this way. And this is the fun part, the part that I always like to make fun about. How do we design systems on slides and whiteboards? You just draw a box, you draw an arrow in between them, and they will talk to each other. And then it's not until you start implementing that they will talk to each other, then you realize how complex that arrow is. And so I used to joke that the hardest thing to implement from a diagram like this is the arrow. Right? Because in this particular case, Axon Server speaks gRPC. So basically, you need to write, low-level code, which you probably don't want to do. But if you are in the Java world, you're very lucky, because we have another tool that's called Axon Framework, and our Axon Framework is essentially doing all the heavy lifting for this and gives you very useful abstractions. It gives you abstractions for buses. So it has a command bus, query bus, an event bus, and you can basically say, I'm sending a command, I'm sending a query, I'm sending an event, and you don't really need to care. It handles it all. It also gives you useful abstractions to subscribe to listen for commands, queries, and events. So you can register event processors, event handlers, command handlers, and query handlers. And then you can say, I'm a component and I can handle these types of events. And if such an event appears, it's going to be delivered to you. And it does, all the load balancing and all the things that you would expect from the message router. Axon Framework kind of supports that. Now, that's super if you are in the Java land, which I assume most of you are. And just before getting on stage today, I got the news that we released finally the new product, which I don't have it on slides, but if you are interested in this, you may want to check it out. It's called Axon Synapse, and it's a HTTP bridge to the Axon server. And so essentially, it does everything that Axon Framework does for Java, but over HTTP. So you have endpoints where you can, just using HTTP, send commands, events, and queries, and receive commands, events, and queries, which kind of opens the door for you for other languages, including things like, I don't know, JavaScript standalone and whatnot, or Python for machine learning, or whatever is your favorite tool. And then you can interoperate that with Axon Framework, so you can have a Java application that uses Axon Framework connected to Axon Server, and then you have, I don't know, a Python application that's connected to the same Axon Server through Synapse, and they exchange events, commands, and query following the exact same model. So I think it's pretty powerful. Here is some more information about those products in case you're interested, and a few more information about things around that. So we have this thing called WorkSonic Academy with some courses. Some courses are free, some are paid, but if you are really interested in this, ping me. If you complete the free courses, ping me, I'll give you access to the other ones. There is a Discuss platform where you can talk to not only our team, but the entire Axon community. Initializer is essentially kind of the thing that everyone has now, like start something and it builds the project for you. And my colleague Sarah Torrey is running a podcast called Exploring Axon, which she invites a lot of other people outside of the company, like all the people that I mentioned earlier have been guests there. So very interesting to listen to if you are into podcasts. And I just want to do one shameless plug. I'm personally involved in organizing an unconference in Amsterdam this September. So if anything of those things that you heard about today is of interest to you in terms of architectural concepts, not our products, you may want to attend. We are aimed to be product vendor independent. We are actually, the organizers of the event are heavily looking forward to invite people who are doing the same things but with different technologies. So we can have a conversation, we can share experience, and we can promote, so to say, this way of doing software, not targeted towards a specific product. So if that is something that you want to attend or tell your friends about, QR code should send you straight to the website. So please help promote it or best attend. Now that's all from me today. I hope you learned something. I hope it wasn't all things that you already knew. And then if you want to reach out to me, this is my contact details. I liked Guy's talk yesterday. He's like, I measure my, what is it called? I don't want to spoil the quote. But kind of made me think, like, like developers are measured by the lines of code they produce, or whatever, the lines of closed issues and things like that. It's kind of absurd metric, but it still exists. So people like me in the developer experience field, we are measured by social media followers. So if you liked what I said and you want to hear more about it, you will do me a favor to go and follow in one of those things. I know it's a stupid metric, but that's how it works. Anyways, feel free, of course, to reach out for more. I'll tweet the details about the slides. Actually, I think I've done it many times before because this is not the first time I'm doing this talk. And I think we now we don't have time for questions, or let's see. if we have any questions. Oh, okay. How to deal with writes to be forgotten? Yeah, we have, I can tell you how we deal in general. There's many different ways to do it. We deal with by encryption. Basically, you configure, we have a data privacy module. You configure which data needs to be encrypted. And then when it needs to be forgotten, you just throw away the key. And that data is technically still there, but it's not decryptable. Does Axon Server uses Kafka? No, it's our own implementation. Can you share slides? Of course. Just follow me on Twitter. I'll send a link. How Axon keeps data indefinitely? Well, find me and we can talk about it. That's a very, very long conversation. It's not something I can explain really quick. How Axon Server different from Kafka? Well, it depends on what you mean by that. Again, it's not something I can do in 5 minutes. It's different in a way that it is not only a message router, but it's also an event store, and Kafka is not an event store. So that's the fundamental difference, but there are tons of other differences which we can go in more details in one-on-one conversation. Does Axon have a special cooperation with which cloud provider? We're working on this. There will be an opportunity in some of the famous cloud providers, so you can click a button and run your own instance. Okay, but as far as I know, that's not there yet. What is the next one? Redo logs for changing events. I'm not quite sure what this. Find me, we can discuss this because I don't really understand what this is about. Is not event modeling like revisit UML flowcharts? Ping Adam on any social media and he would be more than happy to explain this in more details for you. I'm not an expert in event modeling, but I'm pretty sure Adam will be happy to talk to you about that. We use distributed command bus based on JGroups. What can cause problems with delay of processing command and method invocation? So yeah, you can skip the whole thing in the middle, like Axon Server and Axon Cloud or whatever, and you can have two independent Java applications with Axon Framework in it and then synchronize over JGroups. But as you realize yourself, that with time comes with some problems. So if you're managing networking stuff is your passion, by all means you can go for it, but be prepared to deal with all those things on your own. Do I have to use event sourcing with Axon? No, you don't have to. I would highly recommend you to, but you don't have to. It's the default. When you create an aggregate in Axon framework, by default it's going to be event sourced aggregate, but you can configure it to be a state stored aggregate, and in that case you provide a storage, which is probably going to be something like JPA or whatever, and then you don't have to do it with event sourcing. But that is a very useful case when you are migrating existing solutions, because if you have an existing solution and you want to migrate it, you may not want to immediately go to event sourcing. So you may want to go state stored first and then update slowly. But if you want to stay with state stored approach, then the only benefit you get is the CQRS, which may or may not be what you're looking for. I would say one of the main benefits you get is if you do use event sourcing. But of course, that's project dependent. All right, I'll be around today and tomorrow. Find me, talk to me. I'm more than happy to share more details with you. Thank you very much again for being here with me today. And I'll see you around. Have a great the rest of the conference, guys.